In the quiet hum of the control room, deep beneath layers of concrete and steel, a handful of engineers monitor the heart of a technology often misunderstood and feared. The clocks tick steadily, marking time in a facility that could hold the key to humanity's future. Outside, the world debates the wisdom of their work, split between hope and skepticism. Yet here, within these walls, lies the promise of an energy revolution that might save our planet. This isn't the story of distant, futuristic dreams, but a present reality humming with potential. As the reactor pulses with life, emitting a soft glow, the true power of nuclear energy begins to reveal itself. Could this be the beacon of sustainable hope we've been searching for? As the world faces the dual challenges of climate change and the increasing demand for energy, the quest for sustainable and clean energy sources becomes more urgent. Among various alternatives, nuclear energy stands out as a formidable solution. Despite public skepticism and historical mishaps, nuclear power offers unparalleled advantages in terms of sustainability, environmental impact, and energy security. This essay will argue that nuclear energy is indeed a sustainable and clean energy source by addressing its low carbon footprint, reliability, efficiency, waste management solutions, and potential for technological advancements. Low carbon footprint. One of the most compelling arguments in favor of nuclear energy is its remarkably low carbon footprint. In the context of global warming and climate change, reducing greenhouse gas emissions is paramount. Nuclear power plants emit negligible amounts of carbon dioxide, CO2, during their operation. According to the World Nuclear Association, the life cycle CO2 emissions from nuclear energy are comparable to those of wind and significantly lower than those of solar, natural gas, and coal. This makes nuclear energy a potent tool in the fight against climate change. The Intergovernmental Panel on Climate Change, IPCC, has repeatedly highlighted the necessity of nuclear power in achieving global temperature targets. To limit global warming to 1.5 degrees Celsius above pre-industrial levels, a significant reduction in greenhouse gas emissions is required. Nuclear energy, with its ability to provide large-scale, low-emission electricity, is crucial in this transition. Unlike fossil fuel-based power plants, which release vast amounts of CO2 and other pollutants, nuclear plants offer a cleaner alternative, making them indispensable in our energy mix. Reliability and efficiency. Nuclear energy is highly reliable, offering a stable and continuous supply of electricity. Unlike renewable sources such as wind and solar, which are intermittent and dependent on weather conditions, nuclear power plants operate continuously, providing a consistent base load of energy. This reliability is vital for modern societies, where energy demand is constant and fluctuations can lead to significant disruptions. The capacity factor of nuclear power plants, which measures the actual output over a period of time compared to their maximum possible output, is impressively high. In the United States, for example, the average capacity factor of nuclear plants is over 90%, far surpassing that of wind, around 35%, and solar, around 25%. This means nuclear plants are operating at near full capacity almost all the time, making them a highly efficient energy source. Efficiency and high energy density. Nuclear energy's efficiency is another point of strength. The energy density of nuclear fuel is vastly superior to that of fossil fuels and renewables. For instance, a single uranium fuel pellet, roughly the size of a pencil eraser, contains the same amount of energy as 1 ton of coal, 149 gallons of oil, or 17,000 cubic feet of natural gas. This high energy density means that nuclear power plants require far less fuel than traditional power plants, reducing the environmental impact associated with fuel extraction, transportation, and storage. Additionally, the advanced technology used in modern nuclear reactors allows for higher efficiency in converting nuclear energy into electricity. Next-generation reactors, such as small modular reactors, SMRs, and generation IV reactors, promise even greater efficiency and safety, further enhancing the viability of nuclear energy as a long-term solution. Waste management solutions. A common criticism of nuclear energy is the issue of radioactive waste. However, advancements in waste management and recycling technologies are mitigating these concerns. Nuclear waste can be effectively managed through a combination of recycling, reprocessing, and secure storage. Recycling and reprocessing nuclear fuel can significantly reduce the volume of high-level waste. For example, France has successfully implemented a closed fuel cycle, where spent nuclear fuel is reprocessed to extract usable materials, reducing the need for fresh uranium and decreasing the volume of high-level waste by up to 90%. This approach not only makes nuclear energy more sustainable but also minimizes the environmental impact. For the remaining waste, long-term storage solutions, such as deep geological repositories, offer safe and secure disposal. Countries like Finland and Sweden are leading the way in developing these repositories, which are designed to isolate radioactive waste from the biosphere for thousands of years. These advancements demonstrate that nuclear waste, while a challenge, is a manageable one, particularly when compared to the ongoing environmental damage caused by fossil fuel combustion. Potential for technological advancements. The future of nuclear energy is promising, with ongoing research and development aimed at enhancing its safety, efficiency, and sustainability. Innovative technologies, such as small modular reactors, SMRs, and generation IV reactors, are at the forefront of this progress. SMRs offer several advantages over traditional large-scale reactors. They are designed to be factory-built and transported to the site, reducing construction times and costs. Their smaller size and advanced safety features, such as passive cooling systems that operate without human intervention or external power, make them safer and more flexible in terms of deployment. SMRs can be integrated into smaller grids or remote locations, providing a versatile solution for diverse energy needs. Generation IV reactors, currently under development, promise even greater advancements. These reactors are designed to be more efficient, producing more energy from the same amount of fuel while generating less waste. Some generation IV designs also incorporate the ability to consume existing nuclear waste as fuel, addressing one of the major criticisms of nuclear energy. Additionally, these reactors are designed with enhanced safety features, such as inherent safety systems that reduce the risk of accidents. Economic competitiveness. Nuclear energy is often criticized for its high initial costs. While it is true that constructing nuclear power plants requires significant capital investment, the long-term economic benefits are substantial. Once operational, nuclear plants have relatively low operating and maintenance costs. Their longevity, with lifespans extending beyond 60 years with proper maintenance, ensures a stable return on investment. Moreover, the cost of nuclear energy must be viewed in the context of its reliability and efficiency. Unlike renewable sources, which require backup systems or storage solutions to compensate for their intermittency, nuclear power provides a consistent and dependable supply of electricity. This reliability reduces the need for additional infrastructure, such as energy storage or backup power plants, which can offset the initial costs. Enhancing energy security. Energy security is a critical concern for many nations, and nuclear power plays a vital role in ensuring a stable and independent energy supply. Unlike fossil fuels, which are subject to geopolitical tensions and market volatility, nuclear fuel sources are more evenly distributed globally. Countries that invest in nuclear energy can reduce their dependence on imported fuels, enhancing their energy security and economic stability. Furthermore, nuclear energy's ability to provide a consistent base load of power makes it a strategic asset in a diversified energy portfolio. By complementing intermittent renewable sources, nuclear power ensures a reliable supply of electricity, even during periods of low renewable generation. This stability is essential for the functioning of modern economies and the well-being of societies. Addressing public perception and safety concerns. Public perception and safety concerns are significant barriers to the widespread adoption of nuclear energy. High-profile accidents, such as Chernobyl and Fukushima, have understandably led to apprehensions about nuclear power. However, it is crucial to recognize the advancements in nuclear safety and the lessons learned from these incidents. Modern nuclear reactors are designed with multiple layers of safety features, including passive safety systems that do not rely on human intervention or external power sources. The likelihood of severe accidents has been significantly reduced through rigorous safety protocols, advanced engineering, and regulatory oversight. The nuclear industry is among the most heavily regulated sectors, with stringent standards to ensure the protection of public health and the environment. Educational initiatives and transparent communication are essential in addressing public fears and misconceptions about nuclear energy. By providing accurate information about the benefits and risks of nuclear power, governments and industry stakeholders can build public trust and support for nuclear energy as a viable solution to our energy challenges. Conclusion. In conclusion, nuclear energy emerges as a sustainable and clean energy source when considering its low carbon footprint, reliability, efficiency, waste management solutions, and potential for technological advancements. While challenges remain, particularly in terms of public perception and initial costs, the benefits of nuclear power are substantial and indispensable in our quest for a sustainable energy future. As we strive to mitigate climate change and meet the growing global demand for energy, nuclear power stands out as a critical component of a diversified and resilient energy portfolio. By embracing and investing in nuclear energy, we can pave the way for a cleaner, more sustainable, and secure energy future.